So now we get to the examples. Find the radius and the interval of convergence for this power series. So the first step is, let's write it as a summation. So I need to take the expanded form that we're given and condense it. And so I start looking at it. I see an x squared, x cubed, x to the 4th, 5 squared, 5 cubed, 5 to the 4th, 1, 2, 3, 4. And so I see that this is going to be n x to the n over 5 to the n. Index starts off at 0, and I get n equals 0 to infinity. So that is my power series. Just looking at this power series, I now notice that it is centered at x equals 0. So I know it's going to converge at 0. All power series converge where they're centered. So the question is how can I get my hands on something of the form the absolute value of x minus a less than r? Well, that is the ratio test. So I take this power series and I perform the ratio test. Now a sub n is n x to the n over 5 to the n. A sub n plus 1 is n plus 1 x to the n plus 1 over 5 to the n plus 1. I take the limit as n goes to infinity. So n plus 1, x to the n plus 1 over 5 to the n plus 1, absolute value. And then 1 over a sub n, that is 5 to the n over n x to the n. So this basically is the limit as n goes to infinity, a sub n plus 1 times 1 over a sub n. And now we have to clean it up. Now, your first thought may be to get rid of the absolute values. I've seen a lot of students make mistakes on that by dropping the absolute values. As long as there is a variable x here, I must include the absolute values. I look at this and say, okay, let's clean this up. Now I'm going to take my n plus 1 here and my n and write it as a separate fraction. I notice that my x to the n plus 1 on top, the x to the n on bottom cancels, leaves a x on top. A 5 to the n plus 1 on the denominator, a 5 to the n will cancel. I'll write out the steps here. Let's rewrite it as x to the n plus 1, 5 to the n, x to the n, 5 to the n plus 1. So since it's the first one we did, I'll write out all the cancellation here. X to the n plus 1 is the same thing as x to the n times x to the first. And now we see that the 5 to the n's cancel, the x to the n's cancel. And so I simplified this down as the absolute value of the fraction n plus 1 over n times x over 5. Now, once you are comfortable with the algebra, you can get here a lot quicker. In other words, it's usually easier to look at this one at the top of the screen here at the far right and just, oh, I have x to the n plus 1 over x to the n, cancels them, leaves an x on top. But you got to be careful in some of the trickier cases. Now at this point, I look at this limit and say, well, this is the only part that has n's in it. As n goes to infinity, that blue fraction I have boxed in blue is going to go to 1. And so this simplifies down to absolute value of x over 5. So the ratio test gives me this result. And now we go back and think about, well, what do I know about the ratio test? So the ratio test tells me that this will converge as long as I get an L value that is less than 1. We know we're going to have to be bigger than 0 because we have absolute values here, bigger than or equal to 0. But if I get an L value that is less than 1, I get the convergence. So I look back at this and say, well, you know, if this is less than 1, then we get converging. So I look at this and say, okay, the absolute value of x over 5 less than 1. That's basically saying absolute value of x over 5 is less than 1, or the absolute value of x is less than 5. At this point, we should recognize that looks basically like x minus a in absolute values less than r. So this tells me that my radius convergence is equal to 5. Now I could have rewritten this as minus 5 less than x less than 5, and looking at this and saying, well, you know, if I take 5 minus a minus 5 and divide by 2, now what is 5 minus negative 5? Well, that's the length of that interval. And so 5 minus a negative 5, that's 10 divided by 2 is once again 5. We also remember that this thing is centered at a equals 0. So remember, 0 is in the middle. So if I go from where it's centered to the edge, the radius could be also expressed as 5 minus 0, which is once again 5. So guys, what I want you to realize is we got 3 different ways to talk about finding the radius convergence. Depending on what type of problem it is, one is usually always nicer than the others. So now I know the radius convergence is 5. So now I look and say, okay, my starting interval of convergence, well, that is this negative 5 less than x less than 5. In other words, that is the part that we got when we got rid of the absolute values and solved so x was in the middle. So I know at bare minimal my interval of convergence is from minus 5 to 5, not including the endpoints. But as I said, the endpoints have to be looked at. And so now we test the endpoints. We have 2 endpoints. Our first one is x equals 5. Now when I say we test the endpoints, what we do is we look back to our summation. I'll just write it here, n equals 0. This is n, I'm sorry, not 5 to the n x to the n over 5 to the n. So here is our series that we're going to test. But when we say test the endpoints, we're saying plug that number into n for x and solve. And so when I do that, I get the series n 5 to the n over 5 to the n, which is the summation of n. Now we use our testing techniques from before. So here's a series. Does it converge or diverge? And we look and say, well, you know, this is going to diverge by the test for divergence. Now, usually on the third test, when we give this type of problem, it's a workout question, and we have students explain what technique are they using to get this being divergent. So you might want to keep that in mind for future reference. So at x equals 5, we get divergent. Now I do the same thing at x equals negative 5, because that was the other endpoint. So this is summation n equals 0, n negative 5 to the n over 5 to the n. I can split the minus 5 to the n as minus 1 to the n, 5 to the n. And this simplifies down to minus 1 to the n times n. Once again, this will diverge by the test for divergence. If I take the limit as n goes to infinity, this does not go to 0. The plus and minus will alternate back and forth. The n grows to infinity, so we get that this diverged. Now, after doing all of this work, now we can get our answer. We know the radius of convergence is equal to 5, and we know the interval of convergence is going to be from minus 5 to 5. Do not include the endpoints. Now, in WebAssign, it requires you to give your answer in interval notation. So this is equivalent to saying that minus 5 is less than x less than 5. So now we have another one. Now the good news is once you get comfortable with this process, it's going to go faster. We don't need to create the summation because we're given it. So we just look and start off with the ratio test. The limit as n goes to infinity. Now we know a sub n is x to the n over n plus 1 factorial. A sub n plus 1 is x to the n plus 1. Replace the n with n plus 1. This becomes n plus 2 factorial. So I get x to the n plus 1 over n plus 2 factorial times the reciprocal of a sub n, so it's n plus 1 factorial over x to the n. So this is my a sub n plus 1, my 1 over a sub n. Now we want to clean this up. So this is x to the n times x over x to the n, and then times, that's n plus 1 factorial. My n plus 2 factorial, that's going to give me n plus 2 times n plus 1. I recognize that that's the same as the top. I'll stop the listing, so I stop it at n plus 1 factorial. At this point, those two things cancel out. My x to the n cancels out. And this whole limit turns into the limit as n goes to infinity of the absolute value of x over n plus 2. So that is our ratio test. Gets it to here. Now when we take the limit as n goes to infinity, well, remember x is a number. X is going to be some number. We don't know what number it is, but it's a number, not really the value, not a variable in that aspect. We're taking our limit with respect to n. So as n grows large, then this whole limit becomes 0. It doesn't matter what number you plug in for x. If you plug in 5, 10, 20, square root of pi, this limit's going to be 0. So this is true for all values of x. So basically, when the ratio test gives you an answer of 0, we know that that series is convergent. We know it's absolute convergent, which tells us convergent. Thus, we get convergent for all x values. This tells me my radius convergence is infinity, and my interval of convergence is minus infinity to infinity. So when that limit goes to 0, that tells you that it's going to converge for all x values, which means you're talking about the entire number line, which means your radius convergence is going to be infinity.